So in this video I'm going to illustrate the process of translating a circuit diagram like I have here into a working breadboard circuit, and I'm going to try to highlight some of the good practices which will result in a neat breadboard circuit that's easy to troubleshoot and that hopefully should work reliably. So I've prepared some of my pieces here. I've trimmed down some of the components like the resistors here to fit neatly into the breadboard, and I've prepared a few wires here. So I'll just show you exactly what I did for the resistors and wires first. What I'm planning to do is to put all of these resistors into the breadboard lying down, meaning that the legs will be going straight down into the breadboard and the body of the resistor will lie flat against the upper surface of the breadboard. So to do that, you just bend the two legs down kind of at 90 degrees like this, and then trim the length of the legs to about 10 millimeters. So you end up with something that looks like that. And that's going to sit very neatly into the breadboard. For the wires, I've trimmed them down to length. Most of the wires that I've trimmed are 4 centimeters long. It's maybe one longer blue one there. But generally for kind of like short connections on the breadboard, I tend to trim to 4 centimeters, and that's kind of quite a versatile length. And I'm stripping the insulation off either end of the wire here, just to a length of 5 or 6 millimeters. So that's all you want to leave exposed in terms of metal at either end of the wire. So it needs to be long enough to go down and make a connection inside the breadboard, but not so long that any metal will be left exposed above the top of the breadboard. So I've done that for all of my wires here. And generally when you're going to work on a breadboard circuit, you know that you're going to need like a bunch of little short connector wires. So I tend to start off, at least for red and black, I'll trim and strip like a good few kind of red and black short wires to start with, and maybe a few other colors if I know what I'm going to need in the circuit. Similarly for the resistors, if I know, you will know if you're working from a complete circuit diagram like this, you'll know how many of each value you need, so you can just go ahead and prepare them like this, and then figure out where to put them later on. I've also trimmed down the legs of the LED, the two LEDs here as well. Okay, so before I actually start putting together the circuit, I thought it would be useful to just highlight where the different nodes are in this circuit, because it kind of helps to be able to refer back then. As I put in each component here, I'll be able to point out which node in the circuit each element is connecting each of its terminals to. So I'm going to do that with these different colored markers, just to help us kind of recognize how many nodes there are in the circuit here. So the first one that I'm going to highlight is the ground node, which is 0 volts. So I'm just going to highlight that with this black marker. So I'm just drawing a line alongside it. Everywhere that I'm drawing this line is part of the ground node. It's all the same node in the circuit. And what we mean by a circuit node is basically all the points which are electrically connected together, so that there's no voltage difference between any two points in this node. And you can see the node isn't just a point in the circuit, it's a whole area within our circuit diagram where all of these points are all connected together, so they're all at the same voltage, which in this case is 0 volts. So this is ground in our circuit. So that's the first node. I think I'll label that as node 0. So I'm going to number the nodes as we go through here. The next node is the positive supply voltage, which in our circuit is 6 volts. So I'm going to color that in red. And this is everywhere that I'm drawing a red line now. So this will be one of the rails on the breadboard, and it'll be connected through components and wires down to all these other points on the circuit here, where you can see it's connected in here. So I'm going to number this node as well. We'll just call this node 1. So the first two nodes, the two most important nodes. Node 2 in our circuit, I think I will, where will I put node 2? I'm going to call this node here node 2. So this is just between the infrared LED, which is part of the TCRT5000, and the 220 ohm current limiting resistor. So I'm not going to give this node a special color, I'll just mark it with the pencil, because although it's obviously important that we connect this resistor to this LED in order for current to flow here and for the LED to come on, we're not going to pay any more attention to the voltage at this node, so I'll just number it and move on. However, this point here is different. So this is between the photo transistor, which is part of the TCRT5000, and this 100k resistor here. So these form a kind of a voltage divider here, but the voltage in the middle is going to go up and down as the sensor detects more or less light falling on it. So the way that this infrared sensor works is going to be infrared light is going to come out of the LED, bounce off a nearby object, and then be reflected back into the photo transistor. So this is going to be a very important point in the circuit here. The voltage will change as the amount of light falling on the sensor changes, and we're going to feed that into the op amp over here. So I'm going to call this node 3, and it's everywhere that I colour in here. So I'm colouring it in blue. Now I personally tend to use blue a lot for kind of information signals within a circuit, so signals that are kind of changing as a sensor detects something. So I'll call that node 3. Next node is in between these two resistors, which form a potential divider here, and this is generating what I'm calling a threshold voltage of 3 volts. So it's exactly halfway between 6 volts and 0 volts, because these are two equal resistors. And the idea here is that the op amp is constantly comparing the two input voltages to see which one's bigger. If the blue signal is bigger, the output's going to go high, and if this signal here is bigger, then it's going to go low. So I'm going to colour my threshold node green, and that feeds into the op amp here. So everything that I'm colouring in green, that's all one node, and we'll label it as node 4. So if the blue signal is at a higher voltage than the green signal, the output here goes high. If the green signal is higher than the blue signal, the output here goes low. So that's what this op amp is doing. It's working as what we call a comparator, comparing the two input voltages and deciding which one's bigger. Now the output node of the op amp, which I'm going to colour in pink, this is what tells us which of those two input voltages is higher. And this node in the circuit is connected to the two different LED circuits at the output. So we've got a red LED down here and we've got a green LED up here. Each one has got a resistor in series with it to limit the amount of current. But basically once the circuit is switched on, only one of these LEDs will be on at any one time, and which one turns on depends on the output voltage of the op amp. So this is going to be node 5. Now there's just two more nodes here, which again, they're not nodes we're going to pay an awful lot of attention to. There's this node here, in between this resistor and this LED. So I'll just call that node 6, and we're not going to pay any attention to that really. Similarly, there's another node here, another binary node. I'll just call that node 7. So we're not going to be particularly concerned with the exact voltage in here. It's really just when this voltage here goes high or low, it's going to switch on one or other LED. So those are the nodes in our circuit, 7 in total. When we put together the circuit on the breadboard, we're going to want to make sure that anything that's connected between two particular nodes, we want to make sure that we're making the exact same connections on the breadboard when we put it together. So what I think I'm going to begin doing is I'm going to lay out the major components, which is the TCRT5000 is going to be the first of those major components. So where am I going to put that? Let's try it here. I'll just spread that out a little bit more. Okay, so the way I'm plugging that in there, I'm kind of splaying out the legs a little bit there. If I just bring this up, actually, you'll be able to see this better. So I've plugged it in with all 4 legs on the TCRT5000 are in separate rows on the breadboard. So it's important that I don't plug 2 of them into the same row. And this way I can connect wires or resistors or any other components I want to each of the legs without, independently. So it's important to note here which side of the TCRT5000 is which. So you can see I've got the LED on the right and the phototransistor on the left. So the LED is the blue eye and the phototransistor is the black eye there. Now, one thing which can cause confusion is that in the circuit diagram, those two are the other way around. So you can see in the circuit diagram, the phototransistor is on the right and the LED is on the left. That doesn't matter though. It's like the layout physically on the breadboard doesn't need to be the exact same as on the circuit diagram. What's important is the electrical connection, so that the same terminals of each component are connected to the same nodes in the circuit. So that's the first kind of major part that we need in the circuit. I'm going to have I'm going to use the red rail at the top of the board here and the blue rail at the bottom. So I'm going to connect my battery pack next. The battery pack is currently switched off, right? So that's going to be, while we build the circuit, the power should be off. So everything along this blue rail is going to be 0 volts. And everything along this red rail at the top is going to be 6 volts. So those correspond to nodes 0 in the circuit and node 1. So those two nodes there are basically going to be our rails here. Okay, next part of the circuit is I'm going to put in the op amp. Now when you put in the op amp, you need to pay close attention to which end is pin 1. So you can see at one end of the chip there's a little semicircular dip, and that tells you which end of the op amp is. It's hard to get that clear on the camera. It just shows you which end of the op amp is the end where pin 1 is. So that's the dip that I'm talking about just up there. So I'm going to place that dip in row 20 on the breadboard. So I'm just going to leave a bit of space in between the op amp and the TCRT5000 so that I'll be able to build in this branch in the circuit here with these two resistors. But I'm also leaving a bit of space at the end here so that I'll be able to put in the LEDs and resistors here. So I think what I might put in next is I can start connecting up some of the power leads here. For the op amp at least, the two first leads that are easiest to put in are the positive and negative power supply. So for the LM358, if you look up the data sheet and you look at the pin diagram, you'll see that pin 4 is the ground connection, or the negative voltage input. So I'm going to use a black wire here to connect pin 4 to the negative rail. So the pin numbering on this chip begins at pin 1 here, which is at the end where the dip is. So it's pins 1, 2, 3, 4, and then the numbering continues on the other side, working up from the other end. So 5, 6, 7, and 8. So we're going to be connecting negative supply to pin 4 and the positive supply to pin 8. So again, I'll just take one of my short red wires here and connect that to pin 8. So that's the power supply to the op amp. We are also going to need to connect power supply to the anode of the LED and to the collector of the phototransistor. So I'm going to use two more short red wires to do that. So these connections that I've just added in, that's from the anode of the LED. I'm connecting that to the red rail. That is this red wire here. So it's going from the anode of the LED through this wire of the through this row of the breadboard, and then through the red wire up to the red rail. So that is this connection here. And the next wire I put in was from the collector of the phototransistor up to the red rail. So that's this red wire here. So again, you need to identify exactly which pin is the collector pin and then connect that with a wire to the rail. Now on the other side down here, you can see that there's two resistors that go. I've got a 220 ohm resistor which is going to go from the cathode of the LED, which is the negative leg of the infrared LED here. It's going to go from there down to the negative rail. So I need to find a 220 ohm resistor. So this one here is, you can see the color code there is red, red, brown. That's the 220 ohm resistor. So I'll insert that between the blue rail, negative rail, and the cathode of the LED. So that's this guy in here. So you can see, if I hold that up there, you can see that I've completed the current path here from the red rail through that wire there, through this row of the breadboard, in through the anode of the LED, through the LED itself, back out the cathode of the LED, down through this row here, and then through this resistor to ground. So what that corresponds to in the circuit is this whole branch here. So going from the red rail through the LED, through the 220 ohm resistor, and all the way to ground. So it's good to try and identify kind of subsections of the circuit that you can build, and you can verify that you've got them in the right place, sort of one piece at a time. Okay, I'm going to put in this 100k resistor next. So the 100k resistor is brown, black, yellow. So that is this one here, brown, black, yellow. And this connects to the emitter of the phototransistor. So I'll put that in there. And again, you can see I've completed that circuit path from the top rail through this row of the breadboard, through the phototransistor, through this row of the breadboard, and then through this resistor here to ground. That is this whole branch of the circuit here, from the rail through the phototransistor, through the 100k resistor, and all the way to ground. So I've completed that branch there. Now there will be a wire coming from here up to the op amp, so that's going to be coming from this node in our circuit here, in between the phototransistor and the 100k resistor. We've got a node on this row of the breadboard, so a wire is going to go from there up to the breadboard, but we'll come back to that in a minute. So I'll put together this voltage divider circuit here with these two 10k resistors. So here's two 10k resistors, and these, think about them on row 16 maybe. So there's one resistor. So that one is connecting from the rail onto row 16. And then I'm going to connect the second one directly to ground at the bottom of the circuit here. I'll put it into row 16 as well. So that's it there. Now at the moment I haven't completed a path for current to flow from the rail through this resistor and through this resistor to ground, because there's no connection in the middle here. So I'm going to need to form a bridge across the central valley of the breadboard there, which I'm going to do with this green wire here. So now I've created that whole branch in the circuit. So this branch here that goes through from the top rail through the first 10k resistor, which is this one here, on through this green wire, which is this green wire here, and then through this resistor to ground. That's this resistor here. And that has given us our 3 volt voltage at this node in the circuit here where I've got the green wire. Now it's important to feed that into the op amp. So we're going to be going into the inverting terminal of the op amp with this reference threshold voltage here. So to do that I'm going to use another green wire. So I'm following the convention here that where I've got a particular voltage signal in the circuit, or a particular fixed voltage in the circuit, that I try to use consistent color coding. So since this is going to be connected to the same node as my green wire here, I'm going to use the same color wire again. So where will I connect this? Let's put it in here. So I've connected from that node here, which is row 16 on this side of the breadboard, into the inverting terminal of the op amp, which is pin 2 on this chip. Okay, I want to connect up the signal from the sensor output into the non-inverting terminal of the op amp, which is the other input to the op amp there. So I'm going to use this longer blue wire to do that. So what I've coloured in blue, the node that I've coloured in blue on the circuit, I'm going to use a blue wire for that. So that's pin 3 on the chip, and it connects back to this node in the circuit here, node 3, which on my breadboard circuit is row 8 on this side of the board. So you can see node 3 is here, it's connected to one end of the 100k resistor. So there's the 100k resistor here, but it's also connected to the emitter of our photo transistor, and you can see that that is the case here as well, that on my circuit this node is also connected to one of the legs of the photo transistor, and it's the negative leg or the collector. So this entire row of the breadboard then becomes node 3, and I've connected the output wire from there to the op amp. That's this blue wire here, which feeds into the op amp. Okay, we're nearly there. So what are we missing? The two LEDs I'm going to put in. Oops, put in one of them up here. Now it's important when you're putting in the LED that you don't get the legs mixed up. So especially if you've trimmed the legs like I have, you need to look very closely at the LED to identify there's like a kind of a flattening on one side of it. You can just about see it there. So there's a flattening on one side of that kind of plastic collar at the bottom of the plastic bead. That flat side tells you which leg is the minus leg. So you can also see, if you look very closely at the kind of metal plates inside the LED itself, you can just about see them there. There's like a larger metal plate and a smaller metal plate. So the larger one kind of looks more like a minus sign, if you think of it that way. So that's the negative leg, and then the smaller plate is the plus leg, or the anode. So put that in there. So I'm connecting the anode, or the positive leg, through the resistor to the rail. Then I'm going to put in, I think I'll put in the second LED on the lower half of the breadboard here. Put this in here. And just to be consistent with my circuit diagram, I'm going to be consistent with my circuit diagram, I'm going to put the resistor, let's put it here, and then I'll put the LED here. Now again, I need to be careful to get the negative leg of the LED on the ground side, so you can see that I've got a connection to ground here. This black wire here is going to connect to the negative rail. So this row of the breadboard, row 29, is now all ground, so it's all connected directly to that rail. So the negative leg of the LED has to be connected to ground, so that's the one on this side. The positive leg of the LED then connects through this resistor to this point here. So I just need to bridge the two of them together at node 5. So I'm going to use a couple of bits of wire to do that. First I'll connect this to this. So that's forming the connection between the cathode of this LED and the terminal of this resistor. So that's this pink wire here, connecting those two. But then I also need to connect the output of the op amp to the same node in the circuit, node 5. So I use a second pink wire to do that. It goes in there. Okay, so I think we're almost ready to test our circuit. If I switch this on, you can see that initially the green light is on, but when something comes into the vicinity of the sensor, it switches over, the red light comes on to say don't go any closer. Basically the proximity sensor has detected something nearby. So that seems to be functioning correctly. Okay, I think that's it. So I'll leave it there.